Suppose you want to connect to a remote Linux system through an SSH connection. There are two ways. One is to connect to it by username and password, and the other is to connect to it by username and keys, which is called passwordless login. A passwordless connection has the following advantages. First, more security. Using the RSA algorithm, the key pairs are almost impossible to crack. Compared with this, your own password is more easily to be compromised. Second, a strong password is always too complicated to remember, but weak ones mean more vulnerabilities. But by passwordless connection, all you need is a file. On the first connection request, the server will send a public key to the client side, and both the server and the client will hold a public key. The public key is used for encryption. The client has to hold a private key, which is only saved inside the client. The private key is used for decryption. The client will send the public key to the server. The server holds a list called authorized keys, and after receiving the public key the client just sent, it will verify if it is inside this list. If the public key does exist in authorized keys, the server will generate a random string and encrypt it with this public key. We call this string challenge. The server will send the encrypted challenge to the client. On receiving the encrypted challenge the server sends, the client will decrypt it using its private key and send the decrypted challenge back to the server. On receiving the decrypted challenge from the client, the server will verify if this challenge is the same as the server's challenge. If it is, the SSH connection will be established. Now, we will execute the following commands on the root account. Add a user to your system. Here, we add Tom. In the future, you should not use root to log into the system. Generate a pair of public and private keys. Append the public key to the authorized keys. Grant proper permission to authorized keys, which is 600 on Linux. Change the ownership of authorized keys to Tom. Get the private key through SFTP. Disable the inheritance of the private key file and change the ownership of this file to the current user. Connect to the server. The public key will be saved in a file named known_host. Modify the SSH configuration file on the server side to reject password connection requests. Change the SSH port to one that is not easy to guess and reject connection requests from the root user for security concerns. Restart the SSHD service. Here, I'm using Windows Terminal and SSH commands. You can use Xshell, PuTTY, or some other GUI tools. Paste in password. We create a user, Tom. Assign Tom a password. And this will create a directory named Tom in the home directory. .ssh is a hidden directory to save keys. Because we are using a root user, we must tell the Linux system on which user we will run the SSH keygen command, and this command will generate two files called id_rsa and id_rsa.pub in .ssh directory of Tom's home directory. id_rsa.pub is the public key, and the other one is the private key. Append the public key named id_rsa.pub to file authorized_keys, the authorized keys list. The authorized keys list must have 600 permissions. Modify the ownership of the authorized keys list. We download the private key through SFTP. Paste in password. Private key is here. Here, we will modify the permission of this private key file. This part might be a little complicated, and you can just copy my commands or do it in GUI. Let's try to connect to the remote server. Okay, we are done. Paste in password. Disable Linux, and if your firewall is working, stop it and set up it later. Please note that is temporary solution to disable Linux without rebooting the server. Let's make some final touches. Modify the SSHD configuration file, that is, sshd_config, to change the port and reject password login and root login permission. Restart SSHD service. Check if SSHD is working. Let's go back to Windows and connect to it through the new port. OK, done. Don't forget disable Selenex permanently.